In Massachusetts, it's very cold, but not too bad. But it would be very cold in the winter. Hello. Okay, so it's recording. Okay, first of all, many of you are not attending the class. I'm okay, but if university policy forces us to just bring you back, be ready. So you might have some excuses. Maybe you couldn't get visa or have a health issue, but in case the university said if they feel cold and they don't want, I should follow the university basically regulations. So regarding your project, I gave comments to many of you. If you got 100, or I put some positive comment, it just means okay, you can keep going. For some of you, I deduct some points. For example, one of you forgot to put descriptive set. Sorry, no, data source. Some of you forgot to talk about data source. For some of you, there is no data dictionary. Something like that. So in case you might lose some points, and some of you actually wanted to do a very hard project. I tell them you can change the topic, because for some of you, I think the project could be very challenging. So I think I didn't grade like 20%. So the remaining 20% would be graded either tonight or tomorrow morning. Any questions from today or previous classes? Today? Today I teach some concepts. So yeah, we need to know something, then do hands-on experiences. I try to have more hands-on experience sessions, but sometimes we have to have some concept reviews. So I don't see any question from your friend over Zoom. Okay, so this week we start a new topic, sentiment analysis and market basket analysis. So it depends on your project, it might be relevant, but in case, if it's not relevant, you might just have some assignments. Basically, the goal of sentiment analysis is looking at some textual document and get some insights from it. For example, what they are talking about, or if a text is positive or negative about some certain topics. Market basket analysis is just for looking at transactions, let's say in an online store or in a like physical store, and just seeing which items could go together. So you can have some, let's say, your store redesign. By the way, I posted the homework 7. In homework 7, you basically make a workflow of your project. If you can't do it in 9, otherwise you can just do it in a piece of paper, take a picture, and you can just put on Word document or PDF and just submit it. So what I mean workflow, you had some standards like ChrisDM. So, and based on that, there's a like data prep module. Maybe you need some basic imputations and like modeling, and then evaluation. On top of that, I said that for your final project, I want you guys to try 2 different ways to improve your prediction performance. So for each way, maybe you can make a branch. For example, in one, you might have different data preparation. In one, maybe you do SVM. In another branch, maybe you do decision tree. So having said that, maybe you try different ways to improve your performance, but you couldn't. That's okay. I just want to see you try 2 different approaches to improve your predictive performance. Any questions regarding your next assignment? If you can do it in 9, but otherwise you haven't learned 9 completely, so Maybe, I mean, you can draw on a piece of paper. But I just want to see you guys know what you want to do. So what is the overall plan? So basically, you just sketch your plan or diagram. So looking at the diagram, I can understand, you know what you're supposed to do. So, and later that we learn more about KNIME, so you can build up on top of your previous knowledge, and instead of drawing on a piece of paper, you put the actual modules or nodes in the KNIME.
Professor, how about assignment 6, which is the predictive survival status of passengers using the provided data? That also we have to use KNIME, right?
Yes, that one you should use KNIME.
Okay, that one we have to use KNIME for sure, right?
If you are happy with Python, or you can use Python and R. But I think
Python, we're just learning the basics.
So, but I think KNIME is easier. I think many of your friends who had so many Python classes, probably they do in KNIME, because in KNIME you just drag and drop. So I already gave you 2 workflows.
Okay.
So for Titanic, you just replace some, let's say data entry might be different, and maybe data preparation could be a little different. But you can just use my workflow and change some parts based on Titanic data. So, or you can Google for a workflow, download from internet, and just work on that workflow.
Okay.
Cool. So I don't want you guys build everything from scratch. So it might takes much more time, and even, you know, we don't have time to just teach you all the notes. It's not, first of all, it's not productive, and I mean, also we don't have time for that. So 2 reasons. Okay, there's a typo here. I should say next few weeks. I put last. So they have some questions. So let me first. Yeah, if I put in this situation, I don't see your friend's questions. Let's say next few topics, maybe. Okay, let me see your friend's question. No question. Perfect. Okay, so I think I already answered your friend's question with assignment 6. So basically, you just make a workflow and predict the Titanic survival rate. Let me go to that assignment again. Yeah, I just need the workflow from you. So yeah, I mean, that is, you can download everywhere. Kaggle is the most common one. So
yeah.
So, and on top of Kaggle, you can just search for Titanic data, so you can find.
What do you think I use 2 different classification algorithms?
Maybe decision tree, random forest, SVM.
Okay.
So different algorithms. And just tell me which one has a higher accuracy.
Okay. So the decision tree also need to construct like our sites, right?
Yeah. Even neural networks. So you don't have to know those methods. Just drag and drop the node. So one time maybe decision tree, another SVM.
So both of them can be done online?
Yeah.
Okay.
And let's say for 2 different classification algorithms, so everything from data entry, data preparation is same. Maybe after data preparation node, you make 2 different branches. One branch you just do decision tree or random forest, another one SVM or neural.
Both those and just one.
Yeah.
In one lifetime.
You can submit 2 names, but I think one is easier if you do it. Yeah.
You say you don't need any other additional documents.
No. Yeah. Maybe if you want to, because I asked which one has higher accuracy, maybe just when you submit, just type which one has a higher. So that's, or you attach a Word document, that's fine.
And for the submission that was due last night, we needed to submit like a presentation, the Tableau file, And the Word document.
Yeah.
Okay.
Also, please don't wait by the last days. So if you wait, I gave you some extensions for the previous assignment, but I don't think it's fair if every time I give extension.
Yeah.
So maybe one time is okay. So for all of you, I give one extension to be fair. I cannot just give extension to one or two people if they just didn't have time. So maybe somebody has a positive COVID test, so or some significant problem, that's okay. But if you just don't have time to do that, it's not fair. So for all of you, you can have one late submission, and I consider as an extension. So, but don't submit like after the semester. So you just have, everything should be submitted, every assignment should be submitted by late November, last day of November. But just one of your assignment, I give you, I just forgive and give extension by even November or whatever. But anything more than one assignment is your fault. And I feel bad if I just give somebody 3 extensions and somebody else just worked hard and submitted much sooner. Okay, so next few topics is about text applications. We review some methods, and later we have some hands-on experiences, and basically we use KNIME to do text mining. So I give you, just make you motivated. So some people use the text mining to read the other people's tweet data, and they can predict which state some certain candidates could win. So for every election, some people use machine learning, read the people's tweet data, and they try to predict who will be the next US president. And having said that, Twitter has 2 income sources. One is just ads. The second one, they sell tweet data. It's like pretty expensive. If you're interested, Twitter give you a free portion, so a very low percentage of all tweets. So it's just for you to learn. But if you want to have actual tweet data, you should pay Twitter. Yeah, it's except for the challenge. So for Adobe Challenge, you also, as long as you are in the Adobe Challenge, I mean, you don't have to submit, but just, I know at least couple of groups, they didn't do almost anything. So if you just wait and you just, if you don't work in your challenge, just keep in mind, you have so many assignments that you should submit. If you win the challenge, yeah, you don't have to, you get A, but just if you don't work for the challenge and you don't work on your assignments, just keep in mind, after 2 weeks, you have too many assignments you haven't even looked at. So anyway, hopefully you win, but just keep in mind what could happen if you don't win and if you don't work for winning and if you can't. Okay, so from your textbook, please read chapter 5 to 56. It's related to sentiment analysis, and it gives you further insights about what does application, methodology, and demonstration of some workflows. So as a brief, so for any machine learning algorithm, the input should be numeric. But you want to look at the people's tweet data, look at some documents, and end up predicting what they are talking about. So how? So you cannot just throw some text into a model and just assume the model would do the prediction for you. So the biggest differences of sentiment analysis from previous method that you have looked at, we have some extra data preparation steps. Basically, we convert a textual document to a numerical equivalent. So we add that steps. So after conversion, you have rows and columns of numerical values. So you can apply any machine learning algorithms that makes more sense and have a better predictive performance. Does it make sense? So we cannot throw textual document into a, let's say, decision tree or random forest and expect to get some results. Similar for image processing. So you might look at the some applications of algorithms who look at the people's X-ray images and try to predict if they have COVID or not, or other applications. So you cannot throw pictures into the model. So you should have some extra data preparation steps, which you convert a picture to a numerical equivalent. After that, you can just use it in your models. Okay, so these are some application of non-numerical analytics. So you can even convert a voice to numerical equivalent. If you can do that, you can apply any algorithm. So brand management, financial markets, politics. I said there's an application of reading people's tweet data and predicting who could be the next president. And government intelligence. So there's an example of the German government. So they look at the people's emails. They say we don't read it, but they look at some sensitive sentences, and they could find a terrorist group by having some algorithms who reads people's email. There's some privacy issues, but just keep in mind they don't record it. They just, or there's no human who knows what you are talking about. They just have some algorithms who look for some sensitive information. It just still might bring some privacy concerns. Any questions so far? But how we can convert textual document to a numerical equivalent? So one of the basic and traditional way, we have a dictionary of positive and negative words. So basically you assign a positive or negative sentiment to your words. Then you can sum them up and see, let's say in a tweet, if your number of positive words is more than negative or not. Let's say there's a tweet saying, Joe Biden is a fantastic president that I love him. So fantastic and love is a very positive, they have positive sentiments. Versus somebody said, today is a cold, boring day. So cold and boring could bring some negative sentiments. Okay, so the document could be a tweet or any document. You just sum up the, basically you tag each part of your document, which are words. Then you sum up some positives, some negatives. And at the end, after collecting everything, you can end up saying if there's a positive sentiment about a specific tweet or text message or email. So let's say, actually I'm oversimplifying it. Later, when you have hands-on experience, you can understand much more. But let's say before presidential election, so people look some, let's say Twitter or other organization, they buy the tweet information, and they look at the tweets, and they might see, oh, so many people are saying positive thing about Joe Biden in Massachusetts. So probably he wins the election. Or maybe it could be they could make some basically business decisions. So they might look at the tweets. Oh, Joe Biden would win in the Massachusetts, so maybe you don't need to have campaign. So maybe in Arizona, there is a 50-50 chance, and based on the tweets, you are not sure if you win or not, and you see there is a chance. Maybe you make a campaign in Arizona. Something could be related to business products. So again, later I show you some examples, but let's say Nike want to make some specific shoes, and they can look at the people's tweets saying that if there's a positive sentiment about this product or not. If there's such a negative sentiment, maybe they can do some promotion for some certain shoe designs. Or I think you can, if you think, you can find a lot more examples. So basically, sentiment analysis helps you to read people's mind in the much cheaper way. So one way you can employ so many people and do surveys, ask them to reach people one by one. Sometimes they don't want to even answer you. You can do phone calls, or you can pay Twitter, read people tweets data, and just using your algorithms, you can guess what they're talking about. So although you might do a lot of modeling and you might pay Twitter or Facebook or other platforms, but it's much cheaper, much faster, and sometimes better, because sometimes when you talk to people, maybe they filter their voice, they are not that much sincere, but in their tweets, they feel more freedom, so maybe they just type whatever is their mind. So again, there's a lot more steps, and I oversimplify. I just want to tell you the benefits and the overall process. I talk about vector extraction later, but basically this is the overall process. So we read our data. So there is a MPQA dictionary. So you assign positive or negative sentiment to some certain words. For some words, maybe the, a, on, it, that, or quotation marks. So, or exclamation marks, they don't have any sensitive. Maybe in data prep, you can exclude them. So you make your corpus much more summarized. Then you can basically count how many positive and negative sentiments you have, and then talk saying that if people have a positive or negative view on certain topics. It could be more challenging, which again, I talk it later. So let's say some words could be much more negative. So cold is a negative word, but terrible is much more negative. So we can assign some weights to some negative or positive words. More interestingly, later you can see you can use words as a variable. So let's say I catch a cold. So catch, cold, catch could be a variable, cold could be a variable. So just assume you have a data frames. So in your data frames, each row is a textual document. Look at Twitter. Each column could be a word. For example, catch could be a column. Cold could be a column. Influenza could be a column. So some tweets or text document could talk about cold, or not. So that value could be 0 or 1. They could talk about influenza 0 or not. So you have several columns of words, and for each tweets or textual document, they could be either 0 or 1, means either you have that word in your textual document or not. So having said that, now we have a data frame. You can so that data frame consists of some word columns that either 0 or 1. So you can apply machine learning algorithm trying to predict one outcome. For example, let me draw here. Let's look at two examples. I have a fever. I cut a cold. I like running. So these are textual documents. I cannot use it for modeling. So let's say I make it to a data frame of these three words: fever, cut, cold, running. And you want to predict if somebody's sick or not. In Titanic, somebody died or not. So your dependent variable could be 0 or 1, or yes or no. So for the first document, do I have fever? Yeah. Yes, so it's 1. Do I have cut? No, right? 0. Oh, you can't. Sorry. Let's see if I can move it. Can you see now? Okay. So in the first sentence, do I have cut? I have a fever. Do you have this word?
No.
No? Do you have cold?
Yes.
I have a fever. No.
Oh, we were seeing the second statement.
Oh, no. What about running?
No.
0. Second document. I don't have fever. I have cut. I have cold.
No. No.
Yeah. Cold, yeah. 0, 0.
Okay.
Cough, cold, running.
0. Not 3.
So let's.
0, 1, right?
So first one is probably 1. Second one could be 1, right? So what about 3?
0, 0, 0, 0.
0, 0,
0, 1,
1,
0.
Look, it's like a Titanic dataset that you have several columns and you try to predict a sentiment. You can apply same here. So you can apply an algorithm trying to predict if they are sick or not using some variables. Again, no worries. There's some nodes that do it for you. But just keep in mind, this is the general concept. So you convert the textual document to numerical equivalent, then you can apply any basically analytical or machine learning algorithms.
So can you take the tweet and put it into the machine learning for it to code it for you, or you have to like kind of put the definition and do the entry manually?
So you have one step which you need to convert your tweets to numerical equivalence is 0 or 1.
Do you do it manually, or
There's a node that you just connect.
Oh,
Otherwise, you cannot apply any statistical machine learning algorithm on text. Whenever you convert to numerical equivalent, the rest is easy. So you're already used to that. Any questions? So this is like, we have some hands-on experience later, and probably I teach it later too. But just keep in mind, this is the overall process. Even for image processing, you cannot throw images into algorithms. There is still some nodes or some parts of your workflow that you convert the image to numerical equivalent, then you can apply any algorithms on top. Let me wait 1 or 2 minutes in case you have questions. I mean, no worries. It's the first time you see such a concept, you might have several questions. But again, today is for concepts. Later, when we go to hands-on experience, these are makes a lot more sense. You see actual text document converted to numerical equivalent, then we apply some machine learning algorithm on top of it. But sentiment analysis, I think the sentiment one was super easy. So you just assign a negative or positive sentiment to each word, and then you basically you sum up how many positive or negative words you have, and then you can say, is it a positive tweet or a negative tweet, or a positive text or negative text? Is there any question about sentiment analysis, the positive, negative things?
How popular is this?
Huh?
How popular is this? Are companies catching up to?
A lot. It's very popular, especially for the marketing sections. They do a lot of sentiment analysis, text mining. Otherwise, you should hire people and do surveys. So if you do sentiment analysis, it's much cheaper. Even in finance, is very important. So do you guys know about Dogecoin?
Yeah.
So do you remember whenever Elon Musk said some random thing, it just could go up some certain. So sometimes he just tweets in the middle of night. So what you either hire somebody 24/7 to just look over all the documents as just tweet. It could be some governmental bans, like I think China had a ban on cryptocurrencies, and they are on the other part of the world, so the news could come in the middle of night. Or there's a country in the Caribbean, what's the name? El Salvador? Yeah. So that government, they adopt Bitcoin, so it just they boost up the prices. So you either hire people to work 24/7, or you might have some algorithms that read the news, and based on what they see in the news, they give you, is it a positive news or negative news? Then you can have some trading bot that based on the news, they either sell or buy your cryptos or stock. So I think the marketing and finance, especially in the cryptocurrency, which is very volatile, I'm pretty sure text one is very important.
What about product launch?
Yeah, next classes, hopefully if I have time, I talk about the Nike example. So people look, the Nike could get a feedback of people, so how they talk about some new products. But usually for the products that are either very well known, like for example, I think some years ago, Michael Jordan, sorry. So Michael Jordan make a contract with Nike, so his Jordan Air was kind of famous. Everybody was talking about, so something like that. Or Shaq. I think Shaq has a famous grill.
Shaq has a what?
Shaq.
Yeah, Shaq the basketball player.
Yeah, he has his own grill brand.
Oh.
That's actually a good grill. I really like. Some people hate his grill, but I really like his grill. So I think you can find it in Target. So yeah, those products should be kind of should people know about that? So if there is an unknown product, nobody talk about it. So how could you find tweets about it?
On what basis do you say that the statement is negative or positive?
There's different ways. One, I told you could do prediction like this. Another one, which we have a hands-on experiences. So you have a dictionary. Some people who know a lot about English literature, they give a positive or negative sentiment to each word.
Okay.
So when you see in a sentence, there's some notes that count how many positive or negative words you have in the document. Yeah, these are really good questions. Hopefully, when we get to the hands-on experiences, these makes a lot more sense. Okay, So the next topic that I'm going to cover is association rule mining or market basket analysis. It all has different names. Basically, it comes, the name is very intuitive. So we want to look at our store, is either online store or basically it could be a physical store, or even in some healthcare application, we want to see which items goes together. So I think all of you, although we are in the COVID era and some of you just came to US, but I'm pretty sure you had some experience buying from Walmart. So if you go, tea bags are near teas, or maybe coffee beans could be near tea, or some of them make sense, right? But sometimes finding the association is kind of difficult. There's a famous example of baby diapers and beers. Probably you heard about that.
Fathers who buy diapers.
Yeah, sometimes you have some subjective idea, but this association rule mining or market basket analysis give you an objective measure. So you might have like thousands of items in your physical store or millions of items in your online store. So sometimes it's kind of hard to find all of those associations. So we need some automatic autopilot way to find all those associations. So who wants to talk about the association of beer and baby diapers?
Basically, guys usually over the weekend they go to buy beer to watch this sports match with their spouses, and they're on their way to get beer, they can buy the diapers. So they kept together, they're reminded of buying the diapers.
Yeah. I'm not sure how it works in the Muslim countries, but other countries. So basically, there's another example. Let's say somebody is looking for buying a laptop. Maybe there's a high association. If somebody buy a laptop, maybe they buy for some guarantee or antivirus or like word processor. So maybe in the Amazon, when you purchase a laptop, they put some associated item next to it. So you can even think of, do you want buy that item or not? I think it may not be that much beneficial for Amazon because it's usually the point everybody's buy. But I think for their competitor like Best Buy, so if you go to Best Buy website and you buy a laptop, they just want to capture as much as money they can from you. So you might go back and say, oh, I forgot to buy an antivirus. So you may next time maybe you go to Amazon. So they try to promote their items. Basically, if they sell more, they make more money. Any questions about association rule mining? So at the summary, so we want to find the association between several items. We want to make more money. We want to sell more items that are correlated with each other. Some items are challenging. Even I'm pretty sure if you never heard about baby diapers and beer, it's kind of hard to guess. So there's other items is even much harder to guess. So you either hire like 20 people to look over all the items could go together, or you use some methods that give you objective measure. Even if you hire many people to look over associations, they have subjective ideas, but if you can have some objective measures, makes your life much more easy. It makes more sense. Again, it could be be used in medicine, like for example, finding diseases that co-occurrence together. So maybe they can, if they find some association, they try to avoid them or consider some countermeasures. Or some genes could be associated to some diseases. So there's a lot of applications. Okay, so I show you some dictionary of association rule mining. No worries. I mean, if you do we do some examples, that looks much more easier. So first line, basically, you just should read association rule of A implies B. A is antecedent, B is a consequent. Again, no worries, I don't ask you to memorize it. I just want to show you the dictionary of it. So there's a word of support, means probability of A or B together. Confidence of B, confidence of probability of B given A equal confidence of A implies B equals support, which we already explained, divided by probability of A. More importantly, we have lift. So lift equal confidence, which we defined before, divided probability of B, or support divided by probability of A times B, or probability of A or B divided by probability of A times B. So if you run some notes and they give you all the lift value, so if the lift value which defined above is more than 1, we have a significant, I mean, the rule is very significant. So what does it mean? That two items might go together. If it's less than 1, we don't have a significant, we cannot find any significant association between two items. Just keep in mind, it doesn't have to be 2 items. It could be 2 items implies 1 item, or 2 items implies 2 items. So it has an A and B section, but A and B could be consist of several items. So here is how we show. So we might say X implies Y, S bracket S percentage, C percentage, which S is just means the value of support and C is the value of confidence. So it's how you should read. So if I give you a problem and say X implies Y bracket S percentage, C percentage, you can see what is the value of support and confidence. Again, no worries. I know there's so many formulas, and again, I don't expect you memorize it. I just want you guys, even if I give you a problem in your final exam, it's open everything. So, but I want you guys give me the lift value, and based on lift value, you can say if there is a significant association between A and B or not. Any questions? So the goal, I don't ask you to prove this mathematical equations. I just, at the end, what I expect from you, just the lift value. And you can calculate the lift based on confidence, support, probability of A or B together, or probability of A and B. Okay, let's look at an example here. So we have 6 transactions. In each transaction, we have some SKUs, which basically just means item codes. So, for example, in the first transaction 112.34, we have 4 items who bought, and this items has the code or SKU number of 1, 2, 3, 4. And we have several transactions that in each transaction, different items are sold. So look at the first, we want to find the support of 1. I'll go back to the formula, but basically support means just the probability of that item in all transactions. For example, support of 1, how many transactions we have? 6. How many transactions 1 is repeated? In transaction first, 4th, and 5th. So 3 times item 1 happened. We have 6 transactions in total. So support of 1 is just 3 divided by 6. So why support of 2 is 6 divided by 6? Yeah, 2 happen in all of them. We have 2 happen 6 times. Also, we have 6 transactions in total, so 6 divided by 6. Same for 3 and 4. I think it's very straightforward. So finding the support. Let's find support of 1 and 2. So it just means probability of these 2 items happen together. And so in first transaction, it happened together. Not second, not third. In fourth, they happen together. And fifth, not sixth. So items 1 and 2 happen in 3 transactions out of 6 transactions. So this is support of 1, 1, 2. Let's do for 1 and 3. So first transaction, fifth transaction. So support is 2 divided by 6, and same for others. Let's look at the support of 3. So 1, 2, 4. First transaction happened together. Yeah, 3 transactions out of 6. I think these tables should be straightforward, right?
Yeah.
How we calculate support. So here might be a little challenging. So what does support means? So again, if it's just 1 item, it's probability of A. If it's 2 items, probability of A or B. If 3 items, A or B or C. So it depends how many items we have. Let's look at the confidence of 1 implies 2. So 1 implies 2. Let's look at here. Means support divided by probability of A. So support of 1 or 2 is how many transactions? We have 1 transaction here. 1 and 2 here, 1 and 2 here. So here is actually what? 3 divided by 6.
Yeah, I should be doing.
And how many times transaction of 1 happened? First, fourth, and fifth. So 3 out of 6. I know it doesn't look that much great, but let me just change the color. So 3 divided 6 divided by 3 divided by 6. So this 3 divided by 6 could cancel in the numerator and denominator. So again, we don't have to put 6 because 6 is either both in numerator and denominator. So maybe we can just cancel them out. Like for example, now opposite way. Confidence of 2 implies 1. So in the numerator, again, no worries. I think later, even if I give you an example, question, you can just go back to the formula. So basically, support divided by probability of 2. Support was 3 divided by 6, and divided by probability of 2. 2 happen in all of them. So again, 3 divided by 6, and denominator 6 divided by 6. And let's just do one of these. Confidence of 1 and 2 implies 4. So what is the support of 1 to 4? How many times 1 to 4 happen together? In the first transaction, first, so 3 divided by 6. So what is support of 1 and 2?
4.
So let's say 1, 2, 3. 3.
Oh, yeah.
So confidence of 1 and 2 implies 4. First means in the numerator, we have the support of all of them together. So, and also in the denominator, we have support of the first part. So support of 1 and 2 is just 1 and 2 here, here, and here. So 3 divided by 6. Ain't no worries. I mean, calculation shouldn't be, I mean, it's first time it's difficult because it's hard to memorize what happened here. But anytime you do just go back and see the formula, just plug the numbers. So you shouldn't worry about that because the calculation, there's no that much of math behind of it. You just go back, see the formula, and just plug numbers, and you do the calculations.
Is the last one be 3 by 6 by 3 by 6?
Okay, let's do the last one. So what is in the numerator, you said?
2 and 4 implies 3. So I said 3 by 6.
3.
Because it comes 3 times. 2, 3, 4.
Okay, what is the denominator?
3 by 6. Yeah.
3 divided by 6? Okay, let me just look. So 2, 4, 3. Happened 1 time, 2 times, 3 times. Yes.
3 times. Yeah?
Yes. 2, 4, 3. And 2, 4, 1, 1, 1, 1. So it should be 4. Because in 4 transactions, you have 2 and 4 together. Oh,
And
sorry,
5
5 times. Yeah, my bad. Yeah, 5 times.
So the first, the numerator will be where 2, 3, and 4 are all in the transaction.
Yes,
And the denominator of the only 2 and 4 is in the transaction.
yes. If you later want to watch the video, it's basically this formula. Support of all together divided by probability of the first part. In the left side, A implies B. Any questions? I mean, I know it could be a little frustrating because there's so many formulas, but if I give it to you in the exam, it's very easy. You just look at the formula, you plug the numbers and just calculate just a simple division. Let me. Yeah, if it, later we have a lift example. So if the lift more than 1, that product should go together. That pair. So maybe it could be 2 items implies 1 item, right? Look at the lower box. So we have confidence of 2 and 4 implies 3. So either way, so it could be a pair of 2 items goes with 1 item. Maybe if you do lift of tea bag and tea implies coffee, maybe there is a high lift. Let me wait 1 or 2 minutes for your friends over Zoom to see if they have questions. Okay, let's calculate lift now, because what we are looking for, we want to look over lift. So we have how many transactions? We have 7 transactions, and we have item A, B, 0, and 1. It's just different coding. So we want to find calculator lift of 1. Sorry, we want to calculate lift of A implies 0. Again, these are just some coding. So if you go back all here, lift means confidence divided probability of B. support divided by probability of A times probability of A times probability of B, or probability of A or B divided by probability of A times probability of B. Okay, probability of A or 0 together, how many transactions they happen together? Yeah, 3 times, yeah. So we have 7 transactions. So probability of support or probability of A or 0 is 3 out of 7. So
sorry, A or 0.
A or 0.
Which means A has to be 0.
No, A or 0 means there's a different mathematical way to say that. It means how many
this is a part of mathematics sets, right?
Yes.
Union 0, right?
Union, yeah.
Yeah. Okay. So can you tell me which one it corresponds to on the table on the side? Which 3 are?
So giving back to here, yes, you're very right. So how many times A or 0 happens? So 1 time here, 2, 3, 4.
That's B and 0, right?
A and 0. A or 0. Union.
A or 0 is 3 times. Not 4.
So
1,
2,
and the 4th one.
3. A happened here.
Oh, A or.
So yeah, I made the miscalculations here. So A or 0, how many transactions A or 0 happened? 1 time, 2 time, 3 time, 4? Oh no, 5 times. 5 times. My bad. 5 times. So 1, 2, 3, 4, and the last one is here 0.
The probability of A happening as well as the probability of 0 happening.
So either one could happen. It's a union. So here, so I should correct it. So instead of 3 is 5. So, okay, where's my calculator? So you can cancel one of the 7s. So 35. So if I didn't make any mistake, it should be 2.1875. You got same thing or different? So let me double check. So parentheses 5 divided by 7 divided by yes, I did correct. So look, so here, based on the lift, do you think item 1 and 0 could go together or not? So if you want to, you don't know what they are, frankly speaking, you just see the code. But look at the lift. Based on the lift value, do you think it doesn't make sense to put these 2 items next to each other in your store?
Greater than 1.
Yeah, there's a significant association between item 1 and 0. So it makes sense or is economical to put them together. So you expect people looking for item 1, they might look for item 0 too. So there's so many messages here. Okay, your friend calculates same thing. So later we have some hands-on experiences. One hands-on experience. So thanks for just correcting my slide. I give you guys. I give others some bonus points. So I think I changed this text. I forgot to update here. So there's miscalculations. So I update and post it on Moodle. So, but anyway, again, so you might see for simple calculations, we just use calculator and it's just for 2 items and 7 transactions. So for a large store, if they might have thousands of items or online, so there are millions of items, doesn't make sense. If you hire people, use calculator, okay, count how many times they went together, calculate the lift. Even with 7 transactions, first we're thinking it happened 4 because we have some, our eyes couldn't catch all of the transactions. So I teach you some NIME notes and some workflows that they automatically calculate the lifts and tell you if those items should go together or not. If you make more money if you put them together. So let's say if you want to design Walmart, so you want people buy whatever they want from your store. You don't want they leave your store and maybe they stop and shop or price shopper or price try and buy the rest that they forgot. So if you find the lists of thousands of items you have and you redesign your store in the more efficient way, you expect that people, if even they forget what they want, when they look at items next to each other, they just click and buy the items.
Because you go in there to buy one thing before you come out, you have so much stuff. You didn't even think about them going to the store or coming out.
Yeah, they are very smart in it. Yeah. I think they have different approaches. Definitely one of them, they calculate the lift of some items and they expect, they just, anytime I go to IKEA, I just buy so many things I didn't expect. And even Walmart, usually I just want to buy 3 or 4 items. I end up just buying like full of.
I have a hack that I usually eat and
Because
then you don't get a coffee.
yeah.
That's usually 22 months.
Yeah, I mean, and then I want you guys to know the concept of lift. What does it mean? But again, in more practical way, we use module and nodes and calculate all the lifts. We don't have time to do 1 million calculations and just calculate everything. So, okay, that's for today. So next class, we have some hands-on experiences. We start with the text mining first. Then in some sessions, we go to predictive text mining and association rule or market basket analysis. I think market basket analysis might be a better name, but both names are true. Any questions? Because I think people over Zoom. Okay, so one of your friends has a question. Tia, could you use your mic? I think it's much faster. Do we have any extension for the assignment 6? So I think you're attending Adobe Challenge, so you have extension automatically. But I already said I don't give extension one by one. All of you can have one late submission. Don't submit your assignment after December. So anything should be submitted by end of November. And you just have one assignment, one extension for one assignment.
So this recent extension is not counted as a one extension.
Huh?
The recent extension you made is not counted as a one bonus extension.
I mean, your last assignment already extended a few days, but some we still couldn't finish. So for them, I give them just one extension for all of the assignments. So if they use it now, they cannot use it later. So what about people who joined the course late? I think one of you joined late, and they can just talk with me. I want to do it to be fair. I don't want to give extension in the not fair. So let's say if you join today, at least for the remaining of assignment, you should do same due date with the others. For the previous assignment, I should see when you join and how many assignments you missed. But at the end, it should be fair for everyone. Yeah, you can use R or Python if it's more comfortable with you. So you don't have to submit through 9. I think 9 is much faster than R or Python, but if you are happy with R or Python, you can do that. Yeah, I don't see any other questions. That's for tonight. Thank you very much, and have a good rest of the week.
Thank you, Professor.
Thank you.
Thank you.
Thank you. So, okay,
Thank you, Professor.
you can have assignment for 4, but if it should be your last extension, I don't give you 2 extensions. Everyone has 1 extension for all the assignments.
Assignment 4 was supposed to be submitted yesterday. That was already extended for us.
Okay.